Database constraints are restrictions that we place on a database to ensure the integrity of the database. The rules or restrictions can be placed on the data as well as on the operations that can be performed on the data. There are three distinct types of constraints that we can place on a physical file: primary key constraint, unique constraint, and referential constraint. DB2400 allows constraints to be placed only on single-member externally described files. Let us look at the primary key constraint. A primary key is a combination of fields in the physical file that has a unique value for every record in the file and is in ascending order. A primary key field cannot have null values. The add physical file constraint command can be used to add a primary key constraint to a physical file. We have to specify the name of the file, the type of constraint, which in this case will be star primary key, a constraint name, and the fields that comprise the primary key. If you do not specify a constraint name, DB2400 will automatically generate one. A constraint name has to be unique within a library. The unique constraint can be used when we want to specify unique values for fields other than the primary key field. These fields have to be in ascending order and can have null values. We can have more than one unique constraint on a single physical file. The add physical file constraint command can be used to add a unique constraint to the physical file. Here we specify the name of the file, the type of constraint as star unique constraint, the fields that make up the unique key, and a constraint name. It is better to specify a constraint name since the physical file can have multiple unique constraints. We cannot use the same set of fields for both the primary and the unique constraints. When the add physical file constraint command is executed for either a primary key or a unique constraint, DB2400 will check the existing records in the physical file. If the field values do not satisfy the constraint, the command will fail. Similarly, once the constraint has been applied, if any attempt is made to insert or update a record that will violate the constraint, DB2400 will signal an error. Let us move on to referential constraints, which we have seen briefly in Chapter 1. Here is an example. A company maintains its sales information in two files: item master and order detail. The item master file consists of two fields, item code and item name, while the order detail file contains the order ID, item name, quantity, and amount for each order that has been placed for a particular item. The item master file will contain a record for each item that the company manufactures, irrespective of whether there is a corresponding order record for the item in the order detail file. The order detail file will contain one record for each order that is placed. It should not contain an order for an item that does not exist in the item master file. We can use a referential constraint to establish a relationship between the two files so that there are no discrepancies. For this, we identify a parent key item code in the item master file, for which there must be an existing matching field in the order detail file. The parent key should be unique and in ascending order. It could be made up of more than one field. Also, a parent key could be a primary key or a unique key. The item master file is called the parent file. Similarly, we identify a foreign key item code in the order detail file. The foreign key can be made up of one or more fields whose attributes match the parent key in the item master file. The order detail file is called the dependent file. Let us now apply these constraints. First, we define a primary key using the add physical file constraint command. Here, we specify item master for the parent file, the type of constraint as star primary key, the constraint name as item CST, and primary key as item code. Similarly, for the dependent file, we specify order detail as the dependent file, type of constraint as star referential constraint, constraint name as order CST, foreign key as item code, parent file as item master, and parent key as item code. We also have to specify two additional parameters, the update rule and the delete rule. Sometimes a record could be deleted or updated in the parent file, causing records in the dependent file to have invalid foreign key references. The update and delete rule parameters are used to specify what needs to be done in such situations. The update rule parameter takes two values, star restrict and star no action. Both these options prevent any updates to the parent file record if it is going to cause an unmatched foreign key value in the dependent file. They behave identically except when an after update event trigger program exists for the parent file. When we use star restrict, DB2400 will check the dependencies before the after update event trigger program executes. Whereas in the case of star no action, DB2400 will first execute the trigger program and then check the dependencies. We will see trigger programs in the next chapter. The delete rule can take one of the following values: star restrict, star cascade, star set null, star set default, and star no action. Star restrict and star no action for the delete rule are the same as those for the update rule. When we use star cascade, all the corresponding records in the dependent file are also deleted along with the parent file record. To use the star set default option, we should define a default value for the primary key in the parent file and also add a record to the parent file that has the default value in the primary key. With the star set default option, when a record is deleted in the parent file, the corresponding foreign key values are set to the specified defaults. The star set null option will set the null capable foreign key fields to null in the matching records of the dependent file, provided that at least one foreign key field is null capable. Dependent records with a null foreign key value do not require a matching parent record. A dependent file in one referential constraint can be a parent file in another constraint. Whenever an update or delete operation is performed on one file that will violate a constraint on the other file, DB2400 will block the operations. For example, if we have delete rule star cascade specified in the first relationship, deleting a record from the item file should result in the corresponding records being deleted from the dependent order file, thereby triggering an action on the sale file as well. But if the sale file has a delete rule star restrict or star no action, DB2400 will block the deletion of records from the order file and also from the item file. One database file can also be a parent for multiple dependent files. In such a case, whenever a record is updated or deleted in the parent file, DB2400 will check all the constraints. Let us now look at the order in which the rules are checked. For an update operation, DB2400 will first check the star restrict rule and then the star no action rule. For a delete operation, DB2400 first checks the star restrict rule followed by star cascade, star set null, star set default and finally star no action. If a referential constraint has star restrict for both update and delete rule, DB2400 checks the constraint first before doing any update or delete operation. For any other rule, DB2400 first performs some operations, and if the constraint fails, the partial changes made to the files will be rolled back. Hence, it is necessary for the files to be journaled in such situations. DB2400 will automatically use commitment control whenever it is required. Let us now move on to the referential constraint states. When we use the add physical file constraint command to define a primary or unique key, DB2400 will check the key values and will either establish the constraint or cause the command to fail if the existing key values do not meet the specified constraint. Referential constraints can have one of 6 possible states: defined and enabled, defined and disabled, established and enabled, established and disabled, established and enabled with check pending, established and disabled with check pending. When we use the add physical file constraint command to define a constraint, the constraint is set to be defined and is automatically enabled. If we do not want to enforce referential integrity when members are added, we can change the state to disabled by using the change physical file constraint command with the state parameter set to star disabled. When members are added to the parent and dependent files, or if the existing foreign key attributes match those of the parent key, the constraint gets established. If an unmatched foreign key value exists, the constraint will become established with check pending. In this state, no input-output operations will be allowed on the dependent file, while only read and insert operations will be allowed on the parent file. We have to use the change physical file constraint command to disable the constraint and then modify the records with the unmatched foreign key values. Once the changes have been made, we can enable the constraint again. There are several other commands for managing constraints, such as work with physical file constraints, display check pending constraint, and edit check pending constraint. The work with physical file constraint command displays a list of all the physical file constraints along with their states. The display check pending constraint command is used to display the dependent file records that do not have a matching foreign key. This is used when the constraint is established and disabled with check pending. The edit check pending constraint command can be used to edit referential constraints that have a check pending status. This completes the chapter on database constraints. Summary. In this chapter, we saw how we could ensure the integrity of our database by placing constraints on the files. We saw the three different kinds of constraints that can be enforced by DB2 400, namely primary key constraint, unique constraint, and referential constraint.